Hi folks, and welcome back to Physics with Captain Rod here, making this video to provide a further example here of vector addition. And what we're going to do here is we're going to talk about the sailboat here. It says here that the boat shown travels 100 kilometers at a compass bearing of 307 degrees. Then it travels 60 kilometers more at a compass bearing of 220 degrees. We're going to go ahead and try to find the resulting displacement and then the bearing that the sailors would have to take to bring it back to port. Bring it back to port. That's bring it back to port. We'll just insert our B there to bring it back to port. All right, so I've already started by drawing these vectors. And all right, so compass bearing means with respect to due north. So, you know, if I draw myself like a compass here, here's north, east, this would be south, west. So compass bearing of 0 would be this way. This is a compass bearing of 90, 180, 270. So this boat, if it's at a compass bearing of 307, right, and in this picture due north is in this direction, and then this would be like 180, 270, 307 is about here, and I believe that that makes this angle 53 degrees. I took 63 minus 307 there. And then I drew this vector to a certain length here. That's now going to represent that 100 kilometers. So I'll go ahead and label its magnitude. All right, the next vector. So here's our sailboat. They then turn to a heading of 220 degrees. And again, in this picture, if due north was this way in the picture, and east this way, so 220 degrees, let's see, would look something like this, 90. 180. Now all the way to here would be 270. 220 would be from north all the way to here. And then if we take 270 minus the 220, that makes this angle 50 degrees. All right, let's go ahead now and draw in our resultant vector. And it would be nice if I had my straight edge tool, but so the resultant vector looks like this. Good enough. Now the resultant vector itself has an x and y component, or we can think of this as like a west component and the north component. We're going to go ahead and find those by taking the first vector, the 100 kilometers, and the second vector, the, what was it, 60 kilometers, I should label that, and breaking them down into components. So here's what that might look like, and I like to use red for my vector components. So the first vector here, this 100 kilometers, let's do this. We could think of this as a vector of this magnitude to the north. I'm going to call that vector A, call it y component. And then this distance to the west, how about we call this vector A, x direction. We can calculate these easy enough. I'm going to go ahead and just do this right now. So AY is adjacent to the 53 degrees, so it's going to equal the hypotenuse, 100 kilometers times the cosine of 53 degrees. Give me a moment here. Get my phone up and running. I get 60.2. And that's cosine of 53. I think I wrote 33 there, but 53 degrees. Cosine of, I did it again, cosine of 53 degrees. And we end up with about 60.2 kilometers. All right. AX here is opposite the 53 degree angle, so it's going to equal 100 kilometers times the sine of 53 degrees. I get about 79.8. Let's just round that to 80 kilometers. Good enough. Now, this is to the left. It doesn't really matter if we call that minus 80 kilometers or we just keep in mind it's 80 kilometers to the left in the picture. We'll take the plus and minuses into account when we add these. All right, second vector here. Let's draw its components. I'm going to call this vector B. So there's BX. BY. I'm a little handicapped without my straight edge tool that I use in my other program here, but please bear with me. So these are supposed to be right triangles. All right, BX is adjacent to the, what was that? Was that 50 degrees? Double checking here. Yeah. So it's going to equal 60 kilometers times the cosine of 50 degrees. I forgot the units. Kilometers there. Okay. I get 38.56. Let's just call that 38.6 is good enough. 38.6 kilometers. Okay, BY is opposite the 50-degree angle, so it's going to equal 60 sine 50. 60 kilometers times the sine of 50 degrees. I get 45.96, let's call that 46 kilometers. Now, whether we call this plus or minus does not matter. As long as we have the direction stored here, we're good. All right, so now, okay, we'll find Rx by adding these two, the x component of A to the x component of B. Now, I'm just going to go ahead and let's just call left positive when we do this, since both these have components to the left. So that's going to be 80 kilometers for AX and 38.6 kilometers for BX. And again, I'm just doing left positive, no reason not to. Oops. Oh, well, there's not really any reason to be using a calculator for this, but all right. 119 kilometers is close enough. And again, that's to the left. I'll just store the sign like this. RY we can get by taking AY and adding BY. Now BY is down, so what we'll do is we're going to call up positive when we do this addition. And then we're going to be taking 692 and subtracting 46. That wasn't 692, that was 69.2, I'm sure, yeah. Okay. Okay, so 23.2 kilometers. All right, so we have our vector components now. So I'm going to go ahead and just draw another quick little sketch here and even lose my scale. So what we know now is that Rx looks like this. Not important that it's to scale. 119 kilometers west, 23.2 kilometers up. There's our resultant vector. Now, I think one of the things, you know, this is, again, right angle. If it doesn't look like a right angle, it's because your screen needs adjustment or something. Just kidding. But, all right, again, a right triangle here. We'll apply Pythagorean theorem. The magnitude of the resultant squared is going to equal 23.2 kilometers squared plus 119 kilometers squared. I'll just put the units off to the side. I'll put kilometers squared there for our units. All right, and let's see. Go ahead and apply Pythagorean theorem. I get 121.2 kilometers. Let's just say that R is approximately 121 kilometers. Good enough. All right, let's find this angle here. We'll call this theta. The tangent of the angle theta there is going to equal 23.2 over 119. Sorry if you hear my dog barking in the background, but oh, and I gotta find my second button on this calculator again. It's kind of hard to find. Oh, there it is. Different color than I'm used to. Okay, so second tangent, 23.2. 19, inverse tangent of, get about 11 degrees. Okay, so now let's chat about what that means. So in our original picture, that ended up being 11 degrees. That, as a compass bearing, would be from here all the way around. That's 270, 280, that's 281 degrees. Now, to answer the question and how to get back, all right, so now the boat's here. They got to go back along the opposite line here. That would be 11 degrees. These are what are called alternate interior angles, or two parallel lines cut by a bisector. And here's due north. So that's a compass bearing of 90 and 11 more, so 101 degrees. So a compass bearing of 101 degrees, throwing out things like water currents and such, would get them home. So again, this video is meant to be second example of how to add vectors. I hope that it has done that for you successfully. Kind of look it over again. Have a great day.